Assalamualaikum warahmatullahi wabarakatuh. To our Dr. Nora Shikin binti Muhammad Noor. We are from Group 7 to present our group project. So our member is Muhammad Afiq Izzuddin bin Muhammad Sani, Muhammad Azim bin Jamil, and me, Nabila Syuhada binti Zain, Nora Shikin binti Jaafar, Sramo Dendi Santoso bin Sumar. So I will continue. My part is introduction. Foundation is the smallest component of a building or common structure that comes into the direct contact with the soil and securely transfer loads from the structure to the soil. Foundation can be divided into two types, shallow foundation and deep foundation. Shallow foundation transfers the heat to a strong present at the shallow depth. The depth foundation shifts the heat to the deeper depth beneath the ground surface. A depth foundation should be recommended if the development building is intended to expand vertically in the future. Foundation is important because it supports the entire load-bearing structure. So our group was assigned a topic to design a foundation of a minimum three-story building for foundation engineering subject. uh, it's required to obtain a block from a different location and identify its characteristic. So next, the soil investigation carried out for the purpose construction site at Kuala Selangor. The project consists of the construction three-story link bungalow unit. The underground condition at a site is prerequisite to the economical design for the substructure element. The purpose of the soil investigation was to provide the following. First, information determine the type of foundation required, shallow or depth. Second, information to allow the geotechnical consultant to make a recommendation on the allowable bearing capacity of the soil. Third, sufficient data laboratory tests to make settlement and swelling prediction. Fourth, location for the groundwater level. And last, information so that the identification and solution of excavation problem can be made. So next, field exploration and testing. The location of the borehole is shown is the soil investigation data. The field tests and sample collection were conducted in the borehole in accordance with the relevant standard code of practice. First, standard penetration test in a soil at regular depth interval and a undisturbed soil sample. We got two types of sample we collect. First, disturbed sample suitable for identification and index property testing purpose at various depths, and undisturbed rock sample for strength test. Standard penetration tests. The standard penetration tests were carried out according to BS 137759 1990 using an open-ended longitudinal split response sample. The sample was driven into the soil by 63.65 kg automatic strip hammer free falling through with a height 750 mm into an angle. The number of blows required to effect 300 mm penetration test drive below an initial penetration of 150 mm city drive was recorded as a penetration resistance on N value. The SPTs were conducted at depth of 1.5 meter interval. The N value and the length of the disturbed sample recovered from the sampler were indicated the borehole logs. The relative density of cohesionless and soil consistent of cohesions being defined based on the penetration resistance N value. The relationship between the N value and relative density and cohesive on Tehegi and Peck, so mechanic in a general practice. Disturbed and undisturbed soil sample. Disturbed and undisturbed representative soil samples were collected during investigation and subsequently sent to laboratory for visual examination and testing. The disturbed soil sample were also collected from the split spoon sample. Laboratory testing, direct shear test and a table limit test. All collected soil samples from the borehole were brought to the laboratory for necessary testing and rechecking the preliminary boreholes. First, direct shear test. The direct shear test determines the consolidated drain strength properties of the sample. The constant strain rate is applied to single shear plane under a normal load, and the load response is a measure. If the test is performed with different normal loads, the common shear strength parameter can be determined. Vertebrate limit test, the plasticity index gives an indication of, among the other things, the reduction in moisture content required to convert a solid from a liquid to a semi-solid state. It gives the range in moisture at which a soil is in a plastic state. The plasticity index may be considered as a measure of the cohesion possessed by a soil.
Hi, Assalamualaikum. My name is Norashkin binti Jaafar, and I would like to explain about our chapter 2, which is our company background. Okay, first, our company name is Reka Bina Consult Sdn Berhad, and our business address at Lot 5B, Jalan of Templer Petaling Jaya, Selangor, Malaysia. So our company was incorporated in the years of 2008 in Petaling Jaya. Reka Bina Consult Sdn Berhad is a wholly owned by a Bumiputra company. Since 2008, our firm offers building service for infrastructure, architecture, design, and management. The main field for the company is civil structure. We have very vast experience in multiple projects. Our company vision is the company will strive to be a top multidiscipline engineering company in Malaysia by offering project incompatibility with international standard for engineering project management, engineering studies, construction and maintenance work. While for our mission is to establish an efficient management that underlines sustainability, constant growth of company and instilling ethic of work for all employers. We also conduct engineering and development activities with an emphasis on being cost management and excellent in a very field to satisfy strict efficiency, on time, safety and environmental concern. So for quality policies, in Reka Bina Consult Sdn Berhad, we always aim to deliver the best qualities and service to our clients within the time frame and budget. The company operates according the quality management system, which complies with the compliance requirement under MSISO 9001 2008 for design, development, civil and structure works. Engineering service in civil, structural project management and quantity surveying are included in the scope of registration. So here is our team. First, Triatmo Dendi Santoso Sumar as our project manager, Muhammad Afiq Izzuddin Muhammad Sani as our general manager, Muhammad Azim Jamil, our site manager, Nabila Shuhada Zain, our site engineer, and me as well, Nora Shikin Jaafar as safety officer.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azim Jamil. Okay, I want to explain about the chapter 3. That is the project structure. Okay, our project construction takes place in a residential area to build 89 units of 40 feet by 85 feet, 3-story living bungalow. Okay, next, this project is located at Kuala Selangor. Okay, then this building is a 3-story living bungalow with 6 bedroom and 3 bathroom. Okay, first we go into the first floor plan. This is the key plan for the ground beam or ground floor. Okay, this is the second floor plan for this drawing. You can see the void and the staircase in the second floor plan. Okay, go to the third floor plan. This is the third floor plan for this drawing. and there has no void for this third floor plan and has a staircase. Okay, for the cross section XX, you can see that the building from the side view. For the cross section YY, you can see that the view from the back or front of the drawing. Okay, this is the elevation view for the architecture plan. This is a pipe putting plan for this drawing, and that's all has a 20 pipe putting. Then we choose lot at a certain column. The column we group into 3 groups. There are 20 columns for this building, and we choose 5 columns only. The lot of the column in this project was divided into group range, which is from 0 to 400 kilonewton. Then there will be a 3 group with the range of 100 to 200 kilonewton. Okay, the maximum load is from column 5, which is 322.3 kilonewton, and the minimum load from C1 is 140.5 kilonewton. Okay, as you can see, this is the first table is total load on column, and the second one is group of load. Okay, that's all from me.
Assalamualaikum. My name is Triad Modendi Santoso bin Sumar, and I will present on the design of foundation. We propose spread foundation for this project, and we use the Zagis method to calculate the maximum allowable load and the size of the foundation. This is the calculation for foundation C1. The load from the column is 140.4 kilonewton. The depth proposed is 1.5 meter. Based on the soil information report, we get that the unit weight of the soil is 15 kilonewton per meter cube. The frictional angle is 31 degree. Cohesion is 9 kilonewton per meter cube, and using safety factor of 3. From table 6.1, the NC we get is 40.41, NQ is 25.28, and N lambda is 22.65. Then we calculate the load per area, which is Q, by using this formula. Unit weight of soil, which is 15 kilonewton per meter cube, multiplied by the depth, which is 1.5 meter, and get 22.5 kilonewton per meter square. Then we calculate the load bearing capacity, which is QU equal to 1.3 cohesion NC plus by Q and Q plus 0.4 lambda B and lambda. Then we substitute the information above in the formula and get 1041.6 plus by 135.6 B. After that, we find the maximum allowable load, which is Q all, by the formula of QU divided by safety factor, and get 1041.6 plus by 135.9 B per 3. To find the B, we need to compare the applied pressure to ground, which is 140.4 per B square. We try an error method and get the B, which is 0.39, then run off and get 0.4 meter for the B. Then we substitute the value of B in the load bearing capacity formula and get 1095.696 kilonewton. After that, we find the maximum allowable load and get 365.32, which is bigger than the load from the column, which is 140.4 kilonewton. So that the design is okay. Below is the drawing for the foundation design. Thank you.
Hi, my name is Muhammad Hafizuddin bin Saini, and I will explain about the settlement checking calculation. First of all, I will explain about what is the settlement. Settlement is a soil deformed under the load of foundation structure. The total vertical displacement that occur at foundation level is termed as settlement. That cause of foundation settlement is the reduction of volume air void ratio in the soil. And for the example I will show is for column C1, the proposed size is 0.5 meter times 0.5 meter, Now, first, we need to determine the net allowable bearing pressure, and the formula is Q net and 60 divided by 0.125 and times B plus 0.3 divided by B and power of 2. And the second is we need to determine the settlement in millimeter, which is the settlement need to below 25 mm, and the formula for the settlement is 1.25 qnet over n60 fd, and we put the value in the formula, and for the example we get 12.86 mm and below 25 mm, which is acceptable for this project. That's all for me. Thank you.
For this project to be successfully managed, a team with 5 members was formed to be in charge of this project. The project was based in Kuala Selangor TAS with handling of foundation for 3-story link bungalow. The team set out to retrieve the log and from there determine the sand profile for the site. This enables them to have a clear understanding on what of soil and how deep a pile they need to construct in order to withstand the weight of the bungalow. A total of 5 columns were picked up and sorted into 3 different groups according to its range of total load, kilonewton. Column 1 is in group B, column 2, 3, 4 and 5 were grouped in group C, while no column in group A. The maximum load of the column in each group, which are 0 to 100 kN, 100 to 200 kN and 200 to 400 kN, have been chosen as the load that needs to be designed. A total of 27.20 meter depth of soil with different type of soil were analyzed. In this project, the common soil type is sandy silt. Because of the depth of the soil profile, a shallow foundation, specifically spread foundation, is being suggested to design the foundation. It can also be seen that the QL values in each of the column calculated are greater than the maximum load. Hence, this shows that the foundation support being proposed can handle the load applied to them. For column 1, the proposed size is 0.5 meter multiplied by 0.5 meter. For column 3, 4 and 5, proposed size is 1 meter multiplied by 1 meter. For column 2, proposed size is 1.5 meter multiplied by 1.5 meter. The settlement for each column was also checked to ensure that the soil was unable to be displaced. The values obtained from the calculation show that all of the column settlement were below the minimum 25 mm. Hence, the settlement check was. As for the improvement of the soil, this project is planned to provide drainage system to prevent too much water being drained into the soil. One of the big challenge of excavation work will be groundwater. With existence of drainage systems such as deep well drainage, it can control the groundwater and ensure that the soil is rigid enough for the pile foundation. In conclusion from this project, our group learned how to calculate the design foundation using the method have required in shallow foundation. Based on the calculation, we found that split foundation is acceptable for this building, although the building can get away using pile foundation as it is within the budget set. But even with shallow foundation, the foundation is able to support the building. Generally, spread foundation suitable for low-rise building 1 to 4 stories. Furthermore, it requires a firm soil condition that are capable of supporting the building in the area of the spread footing. Last but not least, this condition is most widely used because they are most economical, friendly, and also structurally safe.